Hey, good morning. Happy December 1st and happy Thursday. Welcome to Stumbling Over Statistics with Shelly. Just kidding. Um, we're going to try to make this video quick because I had 3 hours worth of dental surgery yesterday and had 2 pins put into my jawbone. But in the meantime, we are going to look at the Pearson correlation and talk about data correlation. So I'm going to share my screen and I'm going to bring you to a set of data. This is called Combined 504 Students 2020. And basically what it is students identified as 504 in grades various 8 through 12 and their district information, their demographical information, and then scores on STAR EOCs. You'll see I labeled this OG for the original gangster data set and made a working copy because I have learned all too quickly that it's imperative you keep a working copy. So what I did was on the working copy, excuse me a minute here while it's being difficult. On the working copy, I took the demographic data and narrowed it down to just what I'm going to be working with. So I kept a unique student ID, I kept student gender, I kept the grade level they were enrolled for these EOCs, I kept their ethnicity and their race, and then I looked at their biology EOC raw scores versus their English 2 EOC raw scores. And I could have used anything as there's a US history, biology, algebra 1, English 1, and English 2 are the 5 EOCs in the state of Texas. But because a lot of this data was collected during the COVID pandemic, we know that there was a year that students didn't test at all. And then there were years that students were promoted without passing EOCs as far as graduating and the like. So once I went and looked, I found that the majority of students had scores by their senior year for biology and English too. So I weeded out all of the data all the way down to take in the biology and the English 2 EOCs. And then I went through and sorted them and sorted them by grade level. So you can see the top of my data starts at 12 and it goes all the way down to some 10th graders. So at this point in the data snapshot, there were no freshmen that had taken either one of the tests. So mostly seniors, a handful of juniors, and some sophomores. So let's talk about what I did and what I found. The first thing I did was select some data and for the test. And I came up with an average or a mean for the English 2 and then for the biology. And you can see that the biology mean raw score was 29.99, etc. And English was 39.05, etc. And then I ran a scatter plot to look at any correlation, if any existed, between biology and English 2 EOCs. So you could look at correlation between biology and English or correlation between English and biology, and actually looking at it here, or you could have run it between any other things. But to explain my chart, this is my correlation between biology and English 2 EOCs. My X value is biology and my Y value was the English 2 EOCs. So the scatter plot plots all the data points. And looking at the data points before I inserted a trend line, I could tell that there seemed to be a correlation because it was heading from bottom left to top right. And we could see that there was some tight correlation. If you look at points like this, you could see there were some outliers, which does affect the data. So as a researcher, you have to make the determination whether you want to leave the data or not. But for this purpose, I just left it so you could look. Then I ran the trend line. And so the trend line sets to confirm what I expected, or what I was seeing with just the data points, that there is a correlation. It's pretty tight among here, and it's moving this way, up to the right, so it is a positive correlation. And then I just started playing with data because it's fascinating to me what Excel can do. And I came up with this cool little R-square score. This is different than what we were looking at, but I'm going to take a minute to explain it because I know it'll be useful. This is pronounced the rho, and it is a correlation strength between two variables. And what it does is this score measures a linear relationship, and the value can fall anywhere between 0 and 1. It's also known as the coefficient of determination. And so it's used most often in business, but it could be used in an educational setting. And what the coefficient of determination does is it's used as a predicative measure. You use it in forecasting, and what it does is it explains the degree to which an input variable, otherwise known as a predictor variable, how it correlates or how it predicts the outcome of a predicted variable. So basically, again, it's looking at if variable X, or how performance on variable X is going to predict the actual outcome of variable Y. So in this case, it's looking at, biology is looking at a predicative outcome for English 2 EOC. As I think I said earlier, this is also known as the goodness of fit, and the range for this score can equal anywhere from 0 to a positive 1. So if you look at my R-square value, you see that it is 0.6887. That's over halfway to 1, so it does tell you that there is a positive correlation between how performance on biology affects the performance on EOC. Exact correlation would have been at 1, so at 0.6 and change, it's headed that way. There's some predicative outcome. But going back to what we were doing, went ahead and highlighted the outliers. So you can see them in red as opposed to the gray dots here. But when I hover over the scatter plot, you can see these little blue circles and how a lot of them line up very closely, or they overlap each other like little mini Venn diagrams. So that was pretty neat. And then I ran correlation scores. And so the correlation between biology and English, or the Pearson R correlation, turned out to be a 0.7927. Now this number falls between -1 and 1. So the fact that it's greater than 0 tells me that I have a positive correlation, and being at 0.79, that's almost 0.8 of the way to 1. So it's a fairly strong correlation. I went ahead and ran data analysis and came up with some raw scores I'd pointed out earlier, the means for biology and English 2, and then just standard error and median and mode. And you could see that there's a higher median and a higher mode on English 2 than on biology. Looking at the standard deviation, which I could have taken my test further and looked at the difference of standard deviations or effector size. Kurtosis and skewness shows me what my bell curve that I just use my mouse would look like as far as height and width. You'll see that there was less of a range on the biology scores. So the biology scores were clustered closer together at 51, whereas the English 2 EOC is at 66. Both scores, there was a minimum raw score of 0. The maximum raw score on biology was 51, and 66 was the maximum on the EOC for English 2. Theoretically, these counts should have been equal. And if I was doing real actual data and running a study or working on my dissertation, I would go back and look to see what the difference was, because they should be exactly equal. Otherwise, there's going to be a slight variation in data. Going back and looking just the way that I had my columns formatted, I was short 1 on biology as opposed to English 2. Like there was no score there. It was a blank cell, whereas there was a score for English 2, and I didn't quickly notice it because my labeling overlapped. And so my confidence level was set at 95%, which is an alpha of 0.05. And looking here, you could see it had a confidence level of 166 for biology, 2.298 for English 2. This is going to be a t-test now that we're looking at. And so this was 2 samples paired. Obviously, the 2 samples were biology and English. Be a two-tailed test, meaning that it's non-directional. It could go either way, positive or negative. This is helpful because if you're looking at a normal distribution, you could make questions and assumptions on null hypothesis and there being correlation or not correlation. And these numbers would show you, depending on where they fell on the curve, whether you would fail to reject the null if it was within the 95% range, or if it was on the 5% outliers on either tail, then you would reject the null. But going back, looking here, we can look at variance. Here I had noticed my differences in scores, so I'd made observations. With a total of 147 student data sets, your degrees of freedom would have been 146. That doesn't necessarily line up with this number. This was just me evening out data and running tests. But you can see with 146 observations, the degree of freedom would be 145 because it's your sample minus 1. So then my t-statistic would look at a negative 12. And then this cool Excel can show me, had I been running a 1-tail or a 2-tail, what my critical value scores would be. No matter how you look at it, it runs outside of the 95% confidence interval, which would then tell you that you would want to reject the null, meaning that there is a difference in correlation between biology and English 2. And I hope that some activity was enjoyable because it just gave me a chance to go through data and data analysis. And I played with several other charts that I didn't insert. But this gives you a brief overview. Thank you for joining me, and I hope to see you next time.